We're continuing with our econometrics final review, and here's question 26. For question 26, you have the following regression. So you have the natural log of quantity, pounds of coffee consumed per capita. You have the natural log of the price of coffee. You have the natural log of income. You have the natural log of the price of tea. You have a time variable. And then you have dummy variables denoting the various quarters, quarter 1, quarter 2, and quarter 3. And for your first question, how would you interpret the coefficients of P, I, and P prime? So for this one, right, we have a value of negative 0.1647. This implies that the price elasticity of demand, or the predicted price elasticity of demand, is negative 0.1647, which is inelastic. We would say that as price goes up by 100%, predicted quantity of coffee demanded goes down by 16.47%, holding all else constant. For the coefficient on the natural log of income, this is an income elasticity of demand, which means that as income goes up by 100%, the predicted quantity of coffee demanded goes up by 51.15%, holding all else constant. Now we can see here that the price elasticity of demand reveals that demand for coffee is inelastic. The income elasticity of demand reveals that coffee is a normal good, and furthermore, because it's a value between 0 and 1, we can say that it's a necessity rather than a luxury. For the coefficient on the natural log of the price of tea, we see that as the price of tea goes up by 100%, predicted coffee demanded goes up by 14.83%. Since this is a positive value, this suggests that the two goods, coffee and tea, are substitutes rather than complements. So we already answered this question. Is the demand for coffee price elastic? And the answer is no. We can see that it's price inelastic because the value is between, the absolute value is between 0 and 1. We already answered this question as well. Are coffee and tea substitute or complementary products? We can see because the value, the sign of the coefficient on the natural log of the price of tea is positive rather than negative. That suggests that as the price of tea goes up, the predicted quantity of coffee demanded goes up in response to that, which suggests that they're substitute products rather than complementary products. How would you interpret the coefficient of t, the time trend? So here we have a value of negative 0.0089, and this is a rate of decline rather than a rate of growth. It's a negative rate of growth. So this suggests that as time goes up by a year, predicted coffee demanded goes down by 0.89%. That's the instantaneous rate of decline. For E, we just answered that, and it's the same value. Negative 0.89% is the instantaneous rate of decline in coffee consumption in the United States. The income elasticity of demand for coffee, we did answer that already as well. It's equal to 0.5115, and that suggests that it's a normal good and a necessity. How would we test the hypothesis that income elasticity of demand for coffee is not significantly different from 1? So this is, again, different from our default null and alternative hypotheses because we're looking at 1 rather than 0, and the t statistics that are always reported are based on values of 0 for the null and alternative hypotheses. So we do need to keep that in mind. So instead of having these null and alternative hypotheses, right, instead we have these null and alternative hypotheses. So we're given the t-value for this test over here. So the t-value that we're actually given here, which is 1.23, is based on these null and alternative hypotheses. So we have to alter the t-value. So we have to solve for the standard error. So the standard error of beta 2 hat is equal to 0.5115, the value of the coefficient, divided by the t-value that we're given. And so we get a value of 0.41585 for the standard error. And so we can solve for the new t-value. We can say, well, we now have the correct formula, right, because we're looking at a null and alternative hypothesis, right, of 1 instead of 0. And so it's the coefficient minus 1 divided by the standard error that we just calculated. And that gives us a value, the actual t-value, negative 1.1747. Now, if we assume a significance level of 5%, degrees of freedom be 58, and the critical t-value is going to be 2. Since 2, the critical value, is greater than the absolute value of 1.1747, we cannot reject the null hypothesis that beta 2 is equal to 1, and therefore the coefficient is not statistically significantly different from 1. Okay, and this was based on a two-sided test with an alpha level of 5%. "60" has been cut off. But we know that it's equal to 2.0. What do the dummy variables represent in this case? The dummy variables represent the various quarters and how coffee consumption varies by quarter. So how would we interpret the dummy variables in this model? Well, we would actually say, because it's a dummy variable on the right-hand side and a natural log, so we have a dummy variable on the right-hand side and a natural log of quantity, or the dependent variable, on the left-hand side, we would say that demand for coffee in the first quarter is E to the negative 0.0961 minus 1%, and we would end up with a negative value, so it would be lower, but since it's negative, we'd say higher in the first quarter than in the fourth quarter, which is the benchmark or omitted category, holding all else constant. And we would do the same, have the same interpretation for all of the dummy variables using the fourth quarter as the benchmark quarter. Okay, so predicted coffee consumption in the first quarter is E to the negative 0.0961 minus 1, or 9.16% higher, rather 9.16% lower than in the fourth quarter, holding all else constant. And the interpretations are similar for the second and third quarters. In each case, we're comparing consumption in that quarter with consumption in the fourth quarter, since the fourth quarter is our reference or benchmark category. So now it's asking which of the dummy variables is statistically significant. We already know that degrees of freedom are equal to 58. We know that the critical value is about 2. So we can automatically tell, knowing that the critical t-value is 2, that this is greater in absolute value than the critical t-value. And this is greater in absolute value than the critical t-value, but this is much less than the critical t-value. So the coefficient on the first quarter dummy variable and the second quarter dummy variable, they're significantly different from 0, but not the third one. Okay. Now you're asked, is there a pronounced seasonal pattern in coffee consumption in the United States? And there seems to be a slight one, although it isn't too pronounced. There's significantly less coffee consumption in the first and second quarters, perhaps due to weather and workload. So we see that the magnitudes are a little bit higher here. This magnitude is extremely low, so there isn't too much difference between the third and fourth quarters, which are the highest. And we can see, because of these 3 negative values, which is probably the next question, that coffee consumption in the fourth quarter is higher than in any of the other quarters. Okay. Which is the benchmark quarter in this example? The benchmark quarter is clearly the fourth quarter, and the results would not change if we chose another quarter as the base quarter. Conclusions would be the same.